We know that for the collision process, okay, we have the momentum conservation. So all the collision process, we think that the momentum is conserved. And we still need to think about what happened to the energy. Okay. In this case, the only form of energy you need to consider is kinetic energy. So for any collision process, kinetic energy may or may not be conserved. Okay. So please note that momentum is always conserved in any kind of collision. But kinetic energy may or may not be so. So in terms of the kinetic energy conservation, we can put all the collisions into two categories. Elastic collision and inelastic collisions. Okay. For the elastic collision, kinetic energy is conserved. Okay. So plus momentum, it has two conserved quantities, momentum and kinetic energy. And for inelastic collision, the kinetic energy is not conserved. Actually, during this kind of process, you have energy loss. Okay, so it's inelastic. But you still have the momentum conservation. That's something you have to pay attention to. Okay, for any collision, momentum is always conserved. Okay, some students are very easy to forget about this fact, so they couldn't find the equation to solve for the problem. And there is a special case in the inelastic collision. It's called the completely inelastic collision. Okay. It happens when two objects stick together after collision. So it's called completely inelastic because during this kind of collision, there is you have the largest energy loss. Okay. So what happens? Please note that for any inelastic collision, you will have energy loss. The kinetic energy is not conserved. But when completely inelastic collision happens, you will have the greatest loss of the kinetic energy. Okay, if they stick together. And the relation between this, please note that, okay, this is elastic, another category is inelastic. And completely inelastic is only a small subset of the inelastic collision. Okay, this is completely. Okay, that's a relationship between the three kind of terminologies. Sometimes people would think that elastic is put the elastic and completely inelastic as two categories. In fact, it's not. Category this and this. Completely inelastic is just a special case. And with this definition, okay, it makes a huge difference when we try to solve a problem. So you can look at for different kind of collision process, you are going to use different kind of equations. For the elastic collision, because you have two conservation laws, so you have both the momentum conservation and the kinetic energy conservation. You can use both of them. For inelastic collision, you can use only one. Okay, momentum conservation. And if we further know that it's completely inelastic collision, or if you know that they stick together after collision, so these two can be reduced to one term. Okay, because they stick together, so they have formed one object with total mass m1 plus m2, and they share the same final velocity u, okay, instead of different one, u1 and u2. Okay, so here, usually for this part, what happens a lot is that students may not pay enough attention to the conceptual difference. So in the problem, if I'm asking elastic collision, then we want to use this equation. Or if I'm asking about inelastic collision, then we want to use these two equations. Okay, so of course that will cost them a lot of points. The situation goes even the worst situation is that in one semester, I ask two problems. One is for the elastic collision, another is for the inelastic collision. And their students completely switched the two, so they did wrong for both, and totally have 4 problems. So suddenly they lose half of the scores, okay, for that test. So you need to be very clear. What is elastic collision? What is inelastic collision? What is completely inelastic collision? Okay, you will use different equation. Okay. So, any question here? Now, we say that the mathematical definition between of elastic and inelastic collision is in terms of the energy loss. Okay, when you don't have energy loss, that's elastic. When you have energy loss, that's called the inelastic. And to characterize, well, of course, there is a big range from the inelastic to completely inelastic. Okay, so usually to calculate the energy loss, we can introduce a coefficient of restitution. Okay, C equals to U2 minus U1 divided by V1 minus V2. Okay, or you can write it like negative U2 minus U1 divided by V2 minus V1. Okay, the same thing. This coefficient of restitution, actually you can see that there are some kind of ratio between the final velocity change, final velocity difference and the initial velocity difference. Okay, so initially you have velocity v1 and v2, so there is some difference between the two velocity. After collision, you get final velocity u1 and u2. Okay, there is some difference. This is the ratio between the original velocity difference and the final velocity difference, and you make a negative sign. That's to make the number to positive. Okay, so that kind of measures how much energy is lost during the collision. Okay, what happens is if you use this one for the elastic collision, C will be 1. Okay, so when the coefficient of the restitution equals to 1, you don't have energy loss. It's elastic collision. For completely inelastic collision, this coefficient equals to 0. You have the largest energy loss. And for inelastic collision, it's some quantity between C and 1. Okay, so you can even firstly so for inelastic collision, it may be greater or equal to 0, but it should be smaller than 1. So it's some quantity between 0 and 1. And physical meaning of this quantity is that it measures the shape change during the collision process. Okay, so you know that even we consider some rigid body, but when the collision happens, in fact, there is a small shape change. Before collision, you have two like perfect spherical shape. During the collision, okay, actually, I'm exaggerating it. Okay, it has some shape change like this. And if it's the elastic collision. After that, they will go back to their original shape. Okay. So that's elastic collision. And completely inelastic collision, so they will keep this kind of permanent shape change, so they stick together like that. Okay. So they lost most of the energy. And the general inelastic collision, they will still separate after the collision, okay? But they will still have a little bit permanent shape change. So they will not go back to the original shape. So they may have a little bit shape change after collision. Okay. You cannot see it, it's very small. But actually there is some shape change here. So the elastic or inelastic collision actually they determined by the shape change or the restoring of the shape change during the collision process. Okay. So for elastic, it will completely go back to its original shape. For inelastic, you have some of the shape change. For completely inelastic, you have a biggest shape change. Okay. And the energy loss actually goes to the shape change part. Okay, it's to change the shape of the